We're back. Man, it feels like it's been a while. What was it, like July 21st? Something or other?
It felt like at least 3 weeks. It's been too long is what it's been.
A shout out to Grady Dixon, by the way. He was awesome. I feel like I took his class again, like legitimately learned a good bit, and I went back and listened to it, and I was like, it's great that people like that have that knowledge and have had the time to research, because I certainly, some of the things he said, I had no idea. So,
Yeah, I think I once again got a C on that podcast, just like I got in his classes, and that is just enough to get the credit and to make me a meteorologist, but I definitely did not retain all the information. So I need to go back and do that too.
I will say, though, some of the book smarts don't translate. See, I was burned so many times when I first got into this business. I remember I missed a high by 11 degrees in Dothan, and I was like, oh my gosh, what did I do wrong? Like 11 degrees? That's bad. Bad.
I've missed it by more. I've missed it by like 15.
Yeah, it's not fun when that happens, but you know what? That is why we are the Weather Wise guys, and every week we're trying to get a little wiser. That's all.
And creative.
And
Evan
creative.
got a little creative.
Yeah, this was fun. Took me forever to do though, because I'm not creative. I must have deleted this several times, but there's a possible thumbnail for our Weather Wise Guys podcast, and yeah, we are not the wisest by any means, but we learn. We like to share, and I feel like we're good at teaching, Wes, or explaining stuff, and that's what I love most about this, is being able to explain the realms of geoscience and weather to all those other nerds out there.
Yeah, what you kind of do and get better at in this industry is just explaining things and teaching things. And even if, you didn't go into school to be a teacher, you're pretty much giving a miniature science lesson 10 times a day in this industry. And eventually you'll get really good at it.
Something that Grady said, and I forgot to bring this up, but he was like, you'll know that you understand the deep facets of weather when you can explain tornado formation to a 5-year-old. And that's so true, because think about trying to explain that to somebody who can't grasp it. It's hard, but going to these schools and everything and teaching, that's one of my favorite things to do, to just discuss weather, and we get practice all the time. So hopefully y'all are learning something from all of this. It's been fun. We're going to keep it going. Wes has some good info. Wes has some good info this week. So anybody a fan of lightning? Because there was a crazy lightning strike. Wes, I'll let you explain this one, because this still kind of blows my mind.
Yeah, I was going for the yeehaw transition there.
Sorry.
No, you're good.
I feel jet lagged.
Are you coming back from traveling?
Yeah, we had vacation last week, so a lot of kids sleeping in a different environment, and it's amazing to me. You change their habitat. That's what I'm calling it. You change a little kid's habitat, and they turn into some sort of little monster. So it was fun, but it was a long week. Not a ton of sleep. So getting back in the swing of things, though.
Yeah, my AC went out last week, and we tried to get my daughter to sleep in like a different room with us in the basement, and yeah, we were up till 2 a.m. So I understand.
Our AC's gone out every single summer since we moved into this house, and every time they come out, oh yeah, it's a great unit. I'm like, yeah, well, why does it keep going out? We don't even have the air blasting. Whatever. That's the pains of summer, and you actually got a really hot pattern coming up, Wes. What are you looking at this weekend, temperature-wise? You in the near 100?
It's gonna be like 90, 95 for the next 3 days. We will not get much lightning.
Not much lightning. That's a good thing, because you are actually a hot spot for some of the more intense lightning strikes.
Yeah. We'll get to all that in a minute. Coming back, so this lightning strike went from, Texas is a pretty hot place, so this will be a good transition. Texas, and specifically Dallas and near Kansas City share the record now for the longest lightning strike ever recorded, ever observed in the entire world. And that's not too surprising in terms of it happening in America, because we have the wildest weather in the world, I believe. Tornadoes don't really occur. I'm sorry. Tornadoes do occur in other places, right, Evan?
Not to the volume and frequency here, though. It's just a perfect setup.
perfect setup. You got that moisture from the Gulf
Oh, the dry
and the
air off
Canadian.
the Mexican plateau, the leeward troughs that come out of the Rockies is just a perfect, just like that. That's exactly it. See, who needs synoptic? That
There you go.
is the perfect figure right there.
It comes through. So you get a bunch of storms and stuff, and this was actually from the Gulf of Mexico to Canada storm. This was from a big cold front that came through, and ironically, I think this was from October. This is from October of 2017.
What? So how'd you just find this?
The researchers at the Georgia Tech GTRI, like I think it's like GTRI, the Georgia Tech Research Institute of Severe Storms, was going through like a bunch of lightning data recently and a bunch of clouds and whatnot. Of course, clouds, just going through clouds. And they realized that this is an absolutely massive lightning strike that went from just south of Dallas to pretty much in Kansas City. Um, so there are kind of two different points where the northern extent of this lightning strike went. One of them, I mean, it's like just outside of Kansas City proper. It's in
Yeah,
like the heart of the suburbs there. That one that is just south of the black dot of Kansas City, and the other one went. That's about an hour and a half east of Kansas City, kind of in between Kansas City and Columbia, Missouri. But that longest point there where the black arrow is, that went from Dallas, and it was 515 miles. Um,
holy cow.
and that's like a 9 hour car ride or something like that. There you go, 515 miles, and you can see it's part of one giant.
So that is
Uh,
that I was wondering when you sent this to me. I said, "Is that over a period? Is that a lapse, or is that literally the charges and the discharge of one?"
I think like that's like connecting together, like they're
That is
like charging and or I guess they're discharged to get the lightning, but it's like it's growing northward with time
that's that's insane.
because the
It's crazy to me too that they're going back and looking at this data because after you told me about this, I started reading some of the AMS articles of people who've studied this, and they're looking at all sorts of things like cloud to ground, but then there's multiple strikes cloud to ground. They're better at detecting cloud to cloud and seeing the distance and also the intensity. There are people who are like documenting all this stuff, and now that we have the technology to do it, they're able to figure stuff out. And I guess go back and look at things like this, 2017.
yeah, there must have been something on like the satellite sensors that really stuck out to them, like maybe just yeah, something clearly made this convective system stand out to them because we get convective systems all the time in the
Right.
Midwest.
I,
But this was it.
I wonder if somebody up in the International Space Station was snapping photos and they just got them developed and they were like, hey, look at that.
It's huge.
Big
I
old
mean,
light.
apparently this thing lasted nearly 8 seconds. And so it would have been, I guess, nearly seven. I'm rounding up too much. 7 seconds of just a pretty good bolt. And it's just positive and negatives connecting to each other as it's growing up. But there are a lot of positives and negatives charges within this cloud. And so that's why you're seeing kind of like a spider would, like a webbing effect as this cloud is growing from Dallas to Kansas City. Yeah, there's October 22nd. So like you would think that
It's an odd,
maybe
odd time of year, too. I wouldn't have guessed that.
yes, it seems like it, right? But
Yeah.
here's my rationale behind it. You're getting October. That means you're probably getting cooler temperatures closer to the surface. So maybe you're having more cloud ice up there. And cloud ice is where the charges are hitting each other to get the lightning. So it's possible that you're kind of getting just a mix of, warm season storms with the cooler air loft to help get that ice particle interaction in a gigantic string of lightning here.
Yeah, for those of you out there who wonder why some systems have a lot more lightning than others, when fronts come through or troughs in the transitional seasons, the cold air gets into the upper levels first. So it reaches us at, 18, 20, 25,000 feet, but we're still warm at the surface. So as these thunderstorms grow, you have a big difference in temperature aloft. and that can really lead to imbalance of charges. And then, of course, as you mentioned, when raindrops and those hailstones hit together, charges just like that.
Ton of lightning. And this never hit the ground, or I shouldn't say that because I didn't read in the scientific article that it hit the ground. But this is essentially a web of bolts that's crawling horizontally across the sky. If that bolt was to hit the ground somewhere, there'd be like a crater in the ground because
Probably.
the charge would be so strong.
I can't imagine the amount of energy that produces in just that one strike alone. In 7 seconds, the amount of power that is hard to wrap your mind around. Um, for those of you wondering what the thunder comes from, lightning is so hot it literally separates the air molecules for a split second, and that sound is think about this: air molecules. It's all around us right now. That is the sound of air molecules slamming back into each other after that void from the lightning. It's just nuts to think that it has that power. So, but yeah, there you have it.
I didn't know
Record
that.
lightning strike. Yeah,
I had
that
no
was a
idea.
slam in air. That's all it is, but it sounds very scary. So, to kind of build off what you were talking about, Wes, is I was looking at several of these, and again, I was reading some stuff that NASA did a big study looking at they studied it from above, and they were able to figure out over time what areas are frequented by lightning, and that prompted them to do a study from the surface. And a lot of what they found is kind of what you said: Texas, Oklahoma, and the rationale for it was that in that part of the country, the clouds can get a little bit higher. Just the development of these thunderstorms allows for higher cloud tops. They were saying 50, even up to 55,000 feet. And you start talking about you're way up there in the atmosphere, very close to the stratosphere. So I didn't realize that either, that that part of the country plays a role. The only area ahead of that is Lightning King is Florida.
Oh, well, it makes sense. Texas, I feel like it has the unfair advantage over all the states because it's like we're gigantic. Half of our state is in Tornado Alley. I am surprised by that. I thought Florida was the leader, but it's Texas.
Yeah, Texas, they need to give something up. They can't have everything, okay? But it is massive state, so it kind of skews the numbers. But I just thought that was interesting, the frequency of the lightning. And then on top of that, Wes, sprites. I don't know how familiar you are with them. I learned about them years ago, but I dove back into them. The storms you were just talking about in Kansas, in Oklahoma, in Nebraska, and Minnesota are some of the highest frequency of these occurrences. So what is this? Well, this is literally looking at the upper levels of the atmosphere. This is above the troposphere. A sprite occurs with an electrical discharge when there's such a powerful strike, positive strike within the top of the troposphere, at the top of the thunderstorm, that it actually causes this electrical discharge that goes up into the stratosphere. And to my knowledge, they're still trying to understand how all of this, works. But you get a strong enough thunderstorm and a strong enough strike, you'll get these. And pilots will see these, especially military that are flying really high because you got to be way up there. But I mean, again, the power with that is it's hard to wrap your mind around.
And I used to think that you needed some sort of like high speed camera to see these, but I don't know. Do you actually? Do you? Do you
I
know?
have no idea. I've never seen
Okay.
one. In fact, when I was looking up images and explainers for this, I had to be careful because I said, this can't be real. I'm reading about it, and it is. It looks like jellyfish tentacles up close.
Yeah.
It's exactly. It looks like some sort of alien. Um, very odd, very bizarre. So
I I think in the sense of like you can see lightning, but if you have a high speed camera, you can see it more definitively. I think you can see sprites like to the naked eye, but maybe the flash rate is a little bit different because if you said that pilots can see them, then pilots aren't walking around, aren't flying around there with a high speed camera. But they are so weird and like so fascinating. But that's a really good point about the whole Kansas and uh, Oklahoma thing. I feel like I only really see these in those two states, or maybe South Dakota or Nebraska somewhere.
Yeah, all those places were mentioned in this article, and you even all the way up into Minnesota, and it just has to do with the atmospheric profile. But you look at so there's your atmospheric height. You get to 50,000 feet, and obviously this thunderstorm's not all the way up, but at the top of a thunderstorm, you have a lot of positive charges, and positive strikes are much more powerful. So if the bolt goes upward towards the stratosphere into a ionically charged atmosphere, because the stratosphere has a completely different composition than down here, it has this reaction, and the whole chain of events. I don't know anything about the elves, so that's for some other time. But blue jets and red sprites. I mean, bit of a phenomenon there. Really cool.
Tendrils. There you go. That's the jellyfish looking tendril.
That sounds jellyfish. Like if I was like, hey,
Yeah.
what's that jellyfish? It's just dragging its tendrils. So,
Tendrils, sprites, yeah, I would love to know more about elves, because it almost looks like a shockwave or something sent
yeah,
off
exactly.
from the sprite.
Like almost like it's hitting a boundary or it's getting so high and then it diffuses or something like that. But
Yeah,
again, I don't know much about those. Just the whole thing is fascinating, and that's a lot of electrical power to get something like that. But another reminder, we have a ton of lightning, and this always surprised me because my house was struck by lightning as a kid. Then we moved, and then it was struck twice. It hit a pine tree in our backyard. It was, over 100 feet tall, took it down, and then our TV got shot and all of our electronics. So I had three lightning occurrences. Only about 20 to 25% of lightning throughout the course of the year is cloud to ground, which is one of the more powerful strikes, usually a positive strike. But the vast majority, 75, 80%, cloud to cloud, about 30 million a year. So
that makes sense. The charges are closer to each other in the cloud than they are on the ground.
and next time you think of a thunderstorm, happening, you know, everything in the atmosphere is it's trying to get back into a balance, a state of equilibrium constantly. That's why we have hurricanes, we have thunderstorms. There's a heat imbalance. There's something there that causes this to form, and then the Earth, in a response, the atmosphere is trying to diffuse that. So heat at the tropics, hurricanes form. They carry heat poleward. With these, you have a huge, you know, difference in charges over an area. That's not good. It's not in balance. As soon as there's a lightning strike for a brief moment, you're back at equilibrium, and then a second later, you're not. But yeah, charge differences and quite a light show if you ever get a chance to see a sprite.
Bro, we need to find a sprite expert now and have them on for weather-wise guys.
Should we go sprite chasing? Just go on a sabbatical? Where'd those wise guys go?
We need like 2 weeks. 2 weeks in Oklahoma. Maybe we can find some. There may not be many tornadoes, but there'll be storms.
Hey, what are you guys doing here? You tornado chasing? No. We're looking for elves and sprites.
Sprites.
So from the atmosphere to this, there's been a lot of our viewers here, Wes, have been interested in the earthquakes. So there was one in the Aleutian Islands several weeks ago. There was another at the border of Russia that prompted that tsunami advisory for the entire west coast of the United States. So I just thought we would talk about this. This is something, one of the cool things about mine and Wes's field is as you're going through and you're learning about how the atmosphere works, you understand the Earth, or you learn about the Earth as a whole, as an entire entity. So we touched on a lot of this. And something I had forgotten about, Wes, how many tectonic plates are there?
Like 4 or 5. Wait. Not type of interactions. How many plates are there?
Yeah. But you're onto something with the interactions. That's another thing.
I don't know. I'm just like 11.
So, okay, you're right in the wheelhouse. So I thought it was 7, and there are 7 massive, like continental type ones or ocean basins, but there's also smaller ones like the Caribbean plate, the Scotia plate down off South Africa, that play a role too. But one of the more prolific boundaries and the more active boundaries around the world is that Pacific plate. It's basically the border of the U.S. It goes down off the coast of South America, all the way down to the Antarctic plate, and then it comes back up by Australia, the Philippines, and it is incredibly, incredibly active, which causes these earthquakes. They're just underwater. So instead of it being an earthquake at a city or wherever else, this is a plate shift by millimeters underwater that can trigger a whole litany of issues with respect to tsunamis. But
Yeah, and just like look at the Aleutian Islands, like they follow that curve perfectly of the Pacific Plate.
and the Aleutian Islands were formed because this boundary, which you were onto something there, there's a convergent, divergent, transform are the three main boundaries. So convergent, exactly what you'd think. You have two plates that are coming together. The Pacific plate is moving towards the North American plate and towards the European plate. So it's trying to dig up underneath. And over time, you dig up underneath, you're going to cause, the growth of these underwater volcanoes and ultimately these underwater mountain ranges, which is what form the Aleutians. It's also why we have tons of volcanoes. You heard of the Ring of Fire?
Oh yeah, always going off.
It borders the Pacific plate perfectly. And it's right where that plate is pushing against the other plates. Now, notice where there's no volcanoes. There's no. It's the part of the plate that's moving away from the Antarctic plate. So it's the Pacific plate's moving north, and that's why you have all these volcanoes and these earthquakes happening in the central and northern Pacific, because that's where the plate's going, and that's where it's rubbing up against and converging with the North American and Eurasian plate.
Wow, didn't know that. I thought the plates were just kind of like moving around in general. I didn't know that they had like an overall trajectory that some of them were heading.
Yeah, so the between the North American plate and the African plate, the Marianas Trench or Mariana Trench, however you say it.
Mm-hmm.
Um, the reason that's there is because you have the opposite happening. They're diverging. So the two plates are moving apart, and you have that huge trench that's forming. So they're moving away from each other. And what's happening in the North Pacific and West Pacific is the whole plate is shifting north, and so the opposite's happening. You're getting these mountain ranges underwater. You're getting these volcanoes that form. So it's very interesting how all of it works. Incredibly slowly, by the way. I mean, when there's an earthquake, I don't even know how to measure how small of a bump between the plates, but they're massive and it's impactful.
Part of our gig of being weathermen is that we're like the station scientists, and not everybody realizes this, but like most people do. It's like, hey, you're really the only one that took a bunch of science classes like
Yeah.
in this building. Everyone else took English. Everyone else is like better at writing.
Oh, so much better. I'm terrible. So bad. It takes me
Like
forever to type up stuff.
yeah, like the grammar at the news department has grammar, writing, everything else down. When it comes to math and science, that's where like our department shines. It's like that's all we did. It's just math and science and not a whole lot of writing.
And what's cool about this, and I tell people this, especially kids when I go to school, is if you have an interest in any of the earth science, we were in geosciences. That was our domain, and then we focused in meteorology. But the geosciences part, you learn about the plate tectonics. You learn about geology. You learn about, we even did some, astronomy study as well, albeit very, very little, but you cover all this stuff, and it's really cool to understand how the planet works. And then also fascinating at how we can be completely wrong with stuff at the same time. So
Planetary geology,
that's it.
I still think it was my least favorite class I have ever taken in
Really?
college. It was it was like a 2 hour, 3 hour long class
Did you
once
take
a
it in the
week.
summer?
No, dude, I took it just like in the semester, and it was tough sledding. And the teacher knew it, and everybody in there knew it, and it was just like, man,
That's too long. Attention spans don't go that long. Doesn't work.
exactly. But I learned a little bit, and
Yeah.
so
No enough.
thanks,
Okay, how
college.
about this then? If I told you to guess how many earthquakes there have been in this vicinity of 2.5 magnitude, which is pretty low but worth noting, since January 1st, what would you guess? Throw a number out.
Okay, so we're like it's August We're probably like 200 some days into the year.
Yeah, I think you're right on it
Um,
actually.
okay. I'm gonna say 669.
669. I don't
Yes.
know what percentage of what you just guessed actually is.
Oh Jesus, that's not even close.
Yeah, I was shocked. So when the Alaskan earthquake happened, I went to USGS and I was filtering through the reports and I thought, holy cow, these happen every single day, multiple times. And it's that active. Now, a lot of these are smaller magnitude. The Richter scale goes from, 1 to 10, and a lot of these are 3 or lower, 4 or lower, and they're not super impactful. But 11,000, that's
This is
insane.
what's the magnitude you were talking about here again?
Oh, this was an 8.6, I believe.
Oh, I'm sorry. These are just earthquakes in general. Like any.
Oh, sorry, 2.5 magnitude and greater. And
Oh gosh.
we've had two this year over 8. That was the one that was at the Russian border underwater, and the other one that was just offshore of the Aleutian Islands. One was a 7.4. The other, I think it was an 8.3 that hit Russia. Either way, it was the strongest in that area.
It was eight or 8.7. I think it was
Was
eight
it
eight.
8? Okay, that might be right. I did a thing on it, but I forget the numbers. I just know it was very impactful. That was on July 25th. And think about that. So I drew this out, Wes. I did, we have this little measurement tool on our weather graphics.
Mm-hmm.
It was over 4,400 miles from the start of that quake to San Diego to Los Angeles. And it was so powerful, they went ahead and issued a tsunami advisory. Again, nothing
Mm-hmm.
came of it. But imagine a wave, albeit underwater. You can't see a tsunami out in the open ocean, contrary to what people think, that it could go 4,000 miles. That sort of momentum. That's nuts.
And like hours too. It
Yeah.
was like three or 4 hours it got across the ocean.
Yeah, it was in Hawaii, a couple hours later, which is just crazy. So another thing these are responsible for, and sorry about these 1980s graphics, but they were really simple. So take what we just talked about, those plates, right? That makes up the crust. Everything, if you think of like the planet as a whole, you can think of it like the crust is like the skin of an apple. It's very, very small in terms of the entire volume. We actually, all the plates, like you mentioned, Wes, you have a good way of putting it, we just kind of drift about because beneath us is a mantle, which is, you know, part liquid. It's so hot that you have melted rock, kind of like asphalt. And so your plates are kind of just like drifting about on this. And beneath that, there's all that magma, lava. And when there's a disruption or a break within that part of the crust, that's how you get a volcano.
Boom. And there are many spots where it's like always coming out, like
Yep.
Hawaii. Would you ever go visit a volcano,
Yeah, I
like
would.
an
I've
active
actually
volcano?
wanted to go and look into the one in Hawaii. I know a lot of people, some of my family that have done it. Sounds nuts, but it'd be pretty cool. I saw
It,
Vesuvius from a distance.
where was that?
Italy.
Oh, okay.
It's the one that buried Pompeii back in, I don't know, the Roman
I
Empire
know.
days.
BC.
BC, yeah, before us, before
So,
Christ.
something. What was it? I don't know. Yeah, it was like way back then. That's pretty cool. That you actually went and saw Mount Vesuvius.
Lauren couldn't understand why I was so fascinated because the you think back in that time and you just hear the ground rumbling, you don't think anything of it. Next thing you know, a massive volcanic eruption is burying your city to where it's no longer in existence. It's just a fascinating, natural disaster, and that is the power beneath that. You have this lava, this kind of liquid magma as they call it, and these volcanoes are at pressure points. It's pushing too hard on the crust, and then it busts through, and you'll get these on the in fault lines, and occasionally in random spots, but scary stuff.
I had to look up when interrupted because my wife used to teach Latin, and so she talked about this, and we were wrong.
Can I guess? Is it
Yeah,
76
but please,
AD? 76
bro, that's pretty
AD?
good. That's pretty good.
I
That's a
learned
heck of a
about it
lot
from that.
better than my guess of
669.
669.
We won't tell Grady.
79 AD.
Oh heck yeah, I was within like 3 years.
You must have retained the information on that tour.
I looked all of it. Yeah, I was way into this tour. It was like a bunch of retirees and me at the front, like listening to everything that this person said. So, but cool stuff,
Would
scary stuff. Krakatoa is one of the more historic, powerful eruptions. That was like back in the 1840s or something like that. But it actually cooled our global temperature because the ash cloud was so vast. It made it all the way up to the plains, and that's way out, in the Pacific. So these things can be powerful. A lot of them aren't, but when they are, they can be scary. So
and then what was the one that blew up like 3 years ago in 2023? Oh, Hunga Tonga.
I'm not familiar with that one.
Okay, in 2023, I just pulled it up. The eruption of the Hunga Tonga, 2022. The eruption of the Hunga Tonga, January 15th, 2022, produced the largest underwater explosion ever recorded by modern scientific instruments, blasting in enormous amounts of volcanic and blah, 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 blah. Yeah, so
I
just
didn't
while
know
we're on the
about that one.
subject, that's
Did
like the biggest, most recent one.
Was there any like repercussions from that? Like, was there tsunami, an impact to land, anything like that?
I don't think so. I don't think there was a tsunami. Just a ton of sulfur oxide, HCl. What is HCl? What is
Hydrochloride. I don't. But chemistry
I,
was my nemesis.
HCl? It's like a very hydrochloric acid, I guess. I thought it was something. I thought it was something simpler than hydrochloric acid. Sulfur, hydrochloric acid, and water vapor all shot up to the atmosphere, and it depleted the ozone in that spot a bunch. Yeah, I'm sure. I know they have done studies on that volcano to see like what type of global atmospheric impacts it's done. I don't know what those are off the top of my head, but yeah.
Interesting. Yeah, they're very, very powerful. These have the potential, and that's why people don't realize there was evidence of volcanic eruptions that happened thousands and thousands of years ago that actually led to global cooling because the ash cloud was that powerful. There's a really cool story of a jet that flew over the Pacific, and it actually flew into an ash cloud, but they couldn't see it, and it caused St. Elmo's fire to occur on the plane. It was the ionization of the ash as the plane flew through, and
Uh,
it clogged the turbines in this jet. I think it was a 747, and they actually lost power. But the pilots didn't know they were flying through an ash cloud. There had been a volcanic eruption. It drifted. It wasn't in the forecast, so they had no clue. When the plane landed, it looked like somebody took sandpaper to the entire shell of the plane because that was ash just stripping away the outer paint of this aircraft. But
I guess yeah. If all that ash is charged with something, and it'll do stuff with the charges on an airplane and
fun fact,
fire.
I've watched like every episode of Air Crash Investigators, so that's where I got that. So fun stuff. What do you think of the hurricane season so far? How do you feel about your forecast?
um, well, we're on the verge of the first hurricane of the season. I think it's like I don't know when it's forecast. Is it forecast to come tomorrow? Maybe
Hold on here.
I gotta look it up.
Oh shoot.
I go ahead.
I'm ruining things as a producer. I'm gonna get through one of these shows
It's
where I don't.
already. I'm seeing the tweets of it. People are saying like it's at 70 miles per hour. I'm sure it can. I'm sure it can go up 4 miles per hour over the next
People are
12 hours.
just, I mean, begging for this to be a storm. There's a fascination with it.
I'm the opposite. I'm saying no. My forecast is for low activity. Relax on this storm. There's also something in the Gulf of Mexico that's being investigated as well to maybe
Yes,
become maybe it can get to a tropical storm.
yeah, I've been watching that one because that showed up on the other side of the Yucatan. And it's moving into the Bay of Campeche. And anytime something forms down there, like gets our attention, being the Alabama coast and everything else. So,
Yeah.
but it didn't look impressive to me. I could obviously be wrong, but
No, you
the,
can't.
that was,
You were right, the most right.
course,
Uh,
course.
the volcano experts, it was a very interesting overlap of the volcano experts became the tsunami experts, and then they picked up and then went to hurricane experts.
Oh, one other thing on tsunamis, because I had several conversations with people. A tsunami is not like in the movies, a giant wall of water. Have you run into that when you go talk to people?
Um, no, I don't think I've gotten too many tsunami questions. We don't really. That's not really a fear we have in this part of the country.
That's fair. I just go and there's kids that are fascinated by tsunamis, and rightfully so. I mean, it's personified in movies. It's scary,
Mm-hmm.
but for those of you who don't know, a tsunami, you could be on a boat in the middle of the ocean and have no clue that one's moving beneath you
Like,
because the water rise doesn't actually occur until it moves up the continental shelf, where it gets more shallow, so that water's forced up. But a lot of times it's just a series of unstoppable waves. They'll come in gently and they'll just keep on coming, which is kind of scary because water's fairly unstoppable. But anyway, random, random thoughts.
no, I get kids asking me pretty much the same question, but in a different way. They're like, "How does a twister form? How does a funnel cloud form? How does a tornado form?"
Yep, and they'll ask it. They'll
I'm like,
phrase it a little
guys,
different because maybe you didn't give them the answer they were looking for. Um, I don't know, but I get that too, and it's interesting the fascination with it, and I do like it.
sometimes you got to be like, "Hey, a twister is actually the same thing as a tornado."
I will get yep.
And you
You're
just
like,
gotta,
wait, then why
I'm
is it
like,
a different? Why is
yeah.
it a different name? Like,
Sometimes I
I
like
don't
to
know.
pull out the whole willy willy thing on them. Be like,
Willy Willy.
Did you
That's
know that?
Australia, right?
Yeah, and it's like a colloquial term. I don't know if that's too proper of a word to use it, but it's like I don't think the Australia Bureau of Meteorology calls them willy willies. They just call them cyclones. But it's like a
Could you imagine
funny
being on the
name
air?
for
We
it.
got a Willy Willy coming our way.
Surfs up for the willy willy. How am I feeling about my forecast? I'm not feeling the confidence level is a little lower because a lot of people that are smarter than me are saying it's going to be above average. So I'm just riding the wave to see what happens here
Yeah,
for the rest of
that's
the
one of
season.
the earlier episodes we did was on the tropical stuff with David because again, I admit I've been down here for several years and I've learned a ton, but there's still some nuances in forecasting that you have to pick up over time, and there's just some things that you're not going to see till you've experienced it. And I've had that, of course.
And I'm just not experiencing it because I'm in the middle of the country and I just don't know. It'd be like if a winter storm went down to the southeast.
Yeah, not good. That does not bode well for us. So
But everybody, I mean, all the major forecast entities are still like above average, above average, above average. Um, and we already put out our forecast 7, so
we
we're
did
sticking to our guns.
sticking to it. I just completely lost this document that I had of the list. I don't know. I did something, and it is disappeared. It is in some sort of weird format, and I don't know. Oh wait,
Well,
here we go.
you got it. Okay.
I think I might got it. But okay, so to give perspective here, we had this graphic up. So I went back to 1991. I went to the NHC archives, and they do a really good job of having in-depth um, research on tracks and everything else back to 91, and it goes further than that, but that's the range I looked at. So June 3rd of 95. There's a caveat to this, but Hurricane Allison, that's pretty early. Tropical season literally starts June 1st, so this was busting out the gates.
Mm-hmm.
And then you look June 18th, Chris, June 25th, Hurricane Alex, 2010. And then, of course, we had Beryl was right behind this. Last year was the 28th, I believe, of June. So, June is a pretty early time for the first hurricane. Um, I was surprised, but would you have guessed that there was first hurricanes of a season in September?
I would not have. I'm sure there are probably like okay, okay. So A B C D E F G H. So that means there were 7 named storms before Umberto. So like the season was already like going on
Yep.
before Umberto got there. It just nothing was strong enough.
I thought it was interesting too. I'm gonna try to pull this up to show. And it's just a Word document. It's nothing fun, but so this is I was putting it in to Word and I put it in order. So you look at some of the names, and there's a lot of course, A's, B's, C's for the early years, but the Umberto obviously getting to H. There were a ton of tropical storms, a ton. It's hard to believe that there were that many tropical storms that did not turn into hurricanes. But even fairly recently, um, I remember 2015 being fairly benign. I was in Dothan at the time, but um, that is mid August, and you're only at letter D. So we have quiet years, we have busy years, and if I don't know if you can see this,
Yeah.
shoot, right here, where I have this question mark, that would be Erin. But look at the dates. If we somehow go um, to like August 20th, it becomes the sixth latest since 1991. Isn't that nuts? You
Yeah, it's
have
like every day.
all of these that have happened between the 15th and the 24th. And that's obviously Erin's going to form, but still interesting. Oh, this is the other thing I want to point out. Okay, you see this nonsense? So in 2016, Wes,
Oh, January 12th.
so I didn't incorporate that because it would skew the average several days. I think it went from July 27th to like July 15th. But January 12th of 2016, I did not remember this initially until I looked at the satellite data. Just a low over Bermuda, the Bahamas, and then ended up being a hurricane for the Azores out in the mid Atlantic.
So
January
weird.
12th.
I mean, I know technically a hurricane can occur any month. We just have hurricane season because that's the statistical period in which most of them occur. And like, there you go. There's your little outlier. January.
Or now you go sit at dinner or lunch, be like, hey, y'all remember that? Or be like, hey, has a hurricane ever formed in January? They'll be like, no, not a chance. And you're like, well, yes, it has.
True or false?
So
A hurricane.
here's the track for Erin. I grabbed this right before the show.
Nice.
For those of you, that's the Leeward, Windward Islands, the Lesser Antilles as a whole, but this will stay north of Puerto Rico, north of the Bahamas. Bermuda might get smacked, though. I've been watching this pretty closely, and there's certain things in the atmosphere that are very much responsible for the direction of things. For example, the mid-latitude cyclones that move through Kansas City in the fall. You look at the winds at in the mid levels, Wes. You see what's pushing that system. Hurricanes very similar. You want to explain the Bermuda High?
Actually, you do it because you're the hurricane expert compared to me.
I'm an expert. I'll go for it. The high that sits over, it's called the Bermuda High. It's like a semi-permanent feature, meaning it's there almost year round. It intensifies, it weakens, it pulses, it shifts. But if this were, for example, take that high and push it closer to Bermuda, that's going to push Erin towards the Carolina coast. If it's out further in the mid-Atlantic, it's going to be a slingshot. So Erin is going to round this corner, and then in a matter of 36 hours, it's going to go from south of Bermuda up towards the Canadian Maritimes. I mean, this is literally going to be slingshot around this, but this is one of those nuances you have to understand is you know where the highs are, you look at your steering winds, and this is going to be one of those cases where it just is in the right spot. It's going to keep this from being a U.S. impact, though Bermuda might take on a bit of a hit there.
And there is a lot of this related to where the storm initiates in terms of being north or south. The further south it gains a core, then it's more likely to get into kind of south of Cuba, south of the Dominican Republic, and then it will it's going to hit something, right? Because once you get south of Cuba, there's nowhere else to go except dissipate, which is unlikely, but it has to hit something once it's locked in the Gulf. And so the further south you go, you're going to generally get carried toward the west and toward more land. And so if the storm gets developed further north, then it has a much better chance of getting picked up by the Bermuda High and curved back off, and then it'll become like Europe's problem eventually.
I wondered this the other day when I was looking at it. I wonder if there's a latitude, an average latitude, that storms favor a more southerly track, and then there's like a critical point where if a storm forms above 22 degrees north, it's more likely to get absorbed by this high. I'd be curious if there's like a stat on that, because you're absolutely right. If they develop too far north, they're not going to turn back to the south, um, or change their course. So it's a
Huh.
insightful thinking there.
Spaghetti plots.
I
Love
love spaghetti.
spaghetti. Love
Love
spaghetti plots.
good old skitty.
And so what you know sorry, I'll speak for myself. What it looks like to me is that this is going to miss the US. Maybe part of the wind field brushes the East Coast and it kind of just curves back out to the Atlantic, and we'll figure that out
Fish storm.
later on.
It's going to clear the Canadian Maritimes. This will go humming as an extratropical low up into the North Atlantic. But
You think so?
yeah, I've just been covering this every day because I think the tropics are fascinating. Plus, you have idiots down here who are posting screenshots of it slamming into the U.S., and it's about giving me a cardiac arrest. It's unbelievable.
Dude, I was going through TikTok like last week,
Oh,
and there was like one of the scare accounts. He was going live, and so I jumped in the comment section and I started like trolling him. And like next to my name is meteorologist, and so he started to get angry. He was like, "Stop trying to take my followers." And I'm like, "I'm not trying to take your followers at
stop
all."
trying to
Like,
get them in some bush league way. I have
well, look, that right there just tells you exactly what you need to know about these accounts. Is that they're not actually trying to give you information. They're trying to get you to follow them, look at their stuff, and they don't even care if you use their stuff or if you're safe or not. Like, they're not trying to give you information. They want your attention to then get money from it. And that's why the guy was angry, because he thought that I was taking money from him when really I'm just trying to tell people that they don't need to be scared.
and it can be, again, a lot of this, it could technically be harmless, but when you start spreading this hyperbole, and there's a page here, it's called Gulf Coast Severe Weather, and whoever it is hides behind a page, but they take one run. I went and looked at all the runs. There was one out of 18 runs that put it in the Gulf, and he screenshotted it, put bold letters, said heads up, massive. I couldn't help myself. The other night, for the first time ever, I went and commented on something. I said, "This is a problem with this industry," and he blocked me and deleted the comment.
Oh
Um,
yeah, oh yeah, that's what they do.
and he's got hundreds of thousands of followers, which also kills me because he puts out BS and gets you know attention. But whatever, such is life. Speaking of BS, that was my forecast with this. Hmm. Look at that low. I swung and missed by 5 degrees.
That was me. That was me last round of competition. I was off by so much on the low. It was bad.
I was guessing that being close to the water and being right on the edge of the Gulf Stream, that it would stay warm overnight. So 73, but not quite. Grady, an honorable second place there. Still, he still got it, and I'll see if I can't get back. I've never led west, not once this year.
Do you want to
Trailed them,
restart? You want to do a
trailed you
fresh
the whole
start?
year, like Mississippi State in a football game.
We're going 4-10 this year.
Four.
4-8. 4-8. 4-8 this year.
I'm pretty sure the over/under in Vegas is like 3 games.
The
But
only reason I got that correct was because I went and looked at the model's performance leading up to that day and how it was behaving with the lows. And I forget what it was. I think like the model was going. Hold on, can you go back?
Yeah.
I'm not trying to brag here. I'm just like explaining like, yes. So the models were going too warm on the lows. And so I just looked at the obs and I was like, okay, I guess I'll just go cooler than what the model has. And it's like,
No, that's great because
there you go.
that's another perfect example. I don't know the area. I'm not familiar with the nuances of the forecasting there. Like here, I know exactly when the GFS is going to be 99. I know how to translate that to 93 because it has a bias. There, I totally missed it, and I didn't look at the previous day lows. In fact, I had a really hard time finding this station.
Same. Like on a map, like where the
Yeah,
numbers are, I was like, where is this? Like,
I
it's the
went to
same thing as, yeah.
ASICs to find it, but anyway, I'll keep trying. We're going across the border, Wes. Toronto.
Have you been to Toronto?
Nope, I've never been to Canada. Been close. I've been to upstate Michigan. Stone's throw, but never Canada.
I've been to Canada. Went to my buddy's Indian wedding in Canada. In Canada.
In Canada, I've never heard of Canada.
In Canada.
How about it?
In July, and it's pretty nice. It was it
I've
was
heard
still warm.
the summers are pleasant and winters are awful. So give and take everywhere.
Sounds like the upper Midwest.
I picked this Sunday. You good with that? The 17th.
Yes.
I'm gonna start studying now. I'm gonna look at all the Climo for the last 7 days.
I figured we'd do something we've never forecasted for Canada before. You can only use global models because none of the American stuff will work. And
no high res. I'm actually not even sure where to find their climate data. I've not tried to look into it yet, but
same.
It'll be fun.
So definitely equal footing here.
This was fun as always. For those of you who've been watching and giving feedback, certainly appreciate it. So it's a lot of fun to do this. I told Wes that this was my favorite part of the week, putting this together.
Same.
But you have a question, you want to learn about something, shoot a message. If you don't like what we're saying, you can do that too. And we'll try to give some perspective and talk about it like Grady did. He was very fair. I loved how he explained. Doesn't attack the fact that you don't know something. Just here's a perspective. Here's what data shows. And it's a good thing to see.
Have we done corn sweat? Did we ever get around to doing that?
No, we talked about, I was at the beach when you texted me that. And Lauren, my wife, had asked me about, she goes, did you hear about the corn? And I said, well, I didn't hear about it right now, but it's essentially, evapotranspiration. It's just the water that's in corn. It adds that moisture in this runaway heat index, just like if you have a steam room. But people were freaking out about it.
Yes, and it happens every year. But I guess this year it was a little extra pronounced because of the timing of it.
Well,
and
the rain totals from the spring and early summer were very significant there, especially in the Corn Belt like Illinois, Ohio, northern Kentucky, Indiana. They had a lot of rain in May and June, and so more water in the ground. I don't know anything about growing corn, but water, there's a lot of water in corn, and it comes out, and it's like a steam room.
Yep. We'll be getting some of that this week not in Kansas City, outside of Kansas City and in northern Missouri, where crops are grown in general. So we'll be getting in on some of that.
Fun stuff. This was fun, Wes. We did a little earth science here. Got to reach back into the old earthquake, plate tectonics.
Let's stay away from planetary geology because not my.
I hope somebody asks you a question about planetary geology.
So, what's the terrain like on Jupiter?
Yeah, I did not do. When I think of space, it kind of stresses me out because we are tiny, 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 tiny. I have a big fear of like a rogue meteor, a rogue planet, just like ripping through the solar system. Because you can't see these things. They're not tied to any gravity or gravitational circulation. Thank God for NASA. They watch out for these giant rocks. That's scary.
They tell us, hey, we're about to die, but they can't do anything about it. But that's all right.
Yeah, that's okay. We'll call up the Armageddon squad, and they'll fly out there and blow it up.
All right, next week's topic, we'll figure it out.
Figure it out, man, and maybe somebody will send us a message. That'd be awesome. So appreciate everybody as always. It's the Wise Guys, Wes Peary, Evan Shapiro. Until next time.